Chuck, what's the temperature outside now?
According to AccuWeather or according to me? Because if it's according to me, damn, it's hot. That's the temperature.
No, go.
Okay, let me look.
Do your thing.
Okay,
what's the temperature?
right now it is 72 degrees.
72 degrees.
Right now.
Outside.
Outside.
Where?
Hoboken, New Jersey.
So it's 72 degrees in Hoboken.
In Hoboken, New Jersey. Right.
Where in Hoboken is it 72 degrees?
All of Hoboken.
How do you know?
Because that Google's just told me.
Wait, so how do you know there's one thermometer, wherever that thermometer is?
That's true.
And that's what it's telling you.
That's what
It's not using thousands of thermometers and taking an average over the total area of Hoboken. What is the area of Hoboken?
1 square mile.
So that's 1 mile by 1 mile.
1 mile, right.
So somewhere in there's a thermometer that gave you that temperature.
Correct.
Okay.
Yes.
And you don't know where that is.
Well, if it read 98.6, I would know exactly where it is.
So we don't care
Right.
where the thermometer is.
No.
Because fractions of a degree don't matter to us.
No.
Even a degree here and there don't matter to us.
What I can feel is what matters to me.
Right. And so we're okay. It's in the low 70s.
Right.
Unless you're completely nerded out, no one's going to come to you and say, could you be more precise?
Right.
It's 72 degrees. Could you be more precise? Oh, by the way, the entire universe is at a temperature that is the same in every direction to 1,000th of a degree. The cosmic microwave background has a temperature that is the same in that direction as it is in that direction. And we can't say that about the rooms we live in our home.
That is true.
Because there's a vent over there, there's a window over here, and there's a pipe over there.
Right.
There is a standard height above the ground where the National Weather Service records its temperatures.
Really?
Yes.
Okay.
And I don't remember what that height is. It's somewhere within the height of a person.
Right.
Why isn't it lower? Because you know what's heating the air? The sun is not heating the air. The sun is an intense source of visible light. The visible light is not absorbed by the atmosphere. How do you know this?
Because it comes through?
Yes, because you can see the sun. Okay? If our atmosphere absorbed visible light, you would not see the sun. Then it hits the ground. Where does the visible light go? It gets absorbed by Earth's surface. Earth's surface then re-radiates it into the air.
Okay.
But not as visible light.
But not as visible light.
You know how you know that? You turn out the lights, the ground disappears. At night, the ground is not glowing.
Right.
Okay?
Right.
All right? Glowing visibly.
Visibly.
But it is glowing in the infrared.
Gotcha.
Okay, so infrared light comes up. If you have infrared trapping molecules in the air,
yes,
such as
methane. Carbon, water vapor.
Carbon would just be soot.
I said carbon dioxide.
No, carbon is like...
No, carbon is the black stuff that comes...
Is it diamonds in the atmosphere?
Right, no.
Diamonds are carbon too.
Carbon dioxide, which is the gas.
Right. People loosely, a little bit irresponsibly, just speak of carbon as a carbon footprint.
Which I just did, and I know so much better.
It's a little bit irresponsible because carbon is not itself an enemy.
I forgot who I was talking to.
Okay. So, in fact, methane has carbon in it.
Yes, it does.
It's CH4. Right. All right. And carbon dioxide has carbon in it.
Yes, it does.
It's CO2.
Right.
And water also absorbs infrared.
Right.
And it does that without carbon.
Without carbon.
Okay. And that warms the air. If the ground is responsible for heating the air, then the closer you get to the ground, the higher the temperature
it's going to get. Right.
Okay.
So now all we have to do to cool the earth is just get rid of the ground. Global warming.
That'll work. You don't have a planet, but right. So you pick a height above the ground that we experience, and that's a nice, sensible place to put the thermometer. Okay?
I got you.
As you keep ascending, you are farther and farther away from the heat source of the atmosphere.
Okay.
You would then expect what to happen?
Nice and cool, man.
Cool.
Yeah.
Temperatures drop.
Right.
In the old days, before air conditioning, people who had the means would go to
higher elevations.
Higher elevations in the summertime.
Oh, there you go.
Where it was cooler.
Hey, we're headed to our place in the mountains.
In the Poconos.
Oh, dear. Will you be joining us?
So, temperature drops.
Right.
And like I said, if you pay attention to this when you're in an airplane, because lately airplanes give you all the data.
Yes.
Okay?
Yes.
And one of them is what the outside air temperature is.
Exactly.
It drops and drops and drops and drops and drops as you get higher and higher and higher. A common temperature you'll see is like 40 below zero. That's what's happening in the troposphere.
Nice. Now tell me what the troposphere is again.
It is where all of our weather comes from. And we fly just
Above?
near the top.
Near the top
of
of it. So we don't go above it. We on the top.
We can, but we don't. Some very high-flying craft, like the U-2,
Right.
that would go into the
Now, do we fly at
stratosphere.
the top of the troposphere because it's
If you're above all the clouds, why fly through clouds if you don't have to? It's less turbulent, and air is thinner, so there's less
resistance
to the movement of the plane.
Then why doesn't the plane fall out the sky, man?
It's going really fast. There's a buoyant force from the air that is there. By the way, but you make an important point. There's an altitude above which it would have to fly really, really, really fast to get enough air going below it to give it the lift.
Gotcha.
So the higher you go, the faster you have to travel to stay flying. So the SST, the Concorde SST, the first and only ever supersonic transport for commercial aviation, that was up at 45,000 feet, around there.
Right.
Currently, we fly in the 30,000,
Right, yeah.
35,000 feet.
Ladies and gentlemen, we've reached our cruising altitude of 37,000 feet, and quite frankly, I'm freaked out.
All right, where was I?
So we're
All right,
in the
temperature's
troposphere,
dropping.
and now we're at the top of the
Top
troposphere.
temperature drops to like 50 below zero.
Okay.
50 to 60 below zero. Then we go to the stratosphere.
Okay.
Something interesting happens in the stratosphere.
Go ahead.
That's where a molecule of oxygen has 3 atoms instead of the normal 2. The O3 molecule, turns out, sees ultraviolet light and it absorbs it, takes it out of action.
Gotcha.
But where does the energy go?
Oh, that's so cool, though.
It's very cool.
That's why we're not dead. Thanks, O3.
Yeah, not dying from skin cancer.
Exactly.
Right? So the UV molecule is completely gone. The persistent absorption of ultraviolet light in the stratosphere causes the temperature to rise because the particles are now getting an injection of energy that gets manifested as the kinetic energy of the particles themselves. And we measure the average kinetic energy as temperature. So, stratosphere, the temperature rises.
Whoa.
Yep.
That's wild.
Here's an interesting fact. Because the stratosphere is warmer than the troposphere, because the stratosphere is heated by the UV absorbing O3 molecule,
right?
What happens to heated gas?
It expands.
It gets less dense and then rises. Okay?
Yeah.
What that means is the boundary between the troposphere and the stratosphere is completely stable. There is no urge for minus 60 degree air to rise.
It's almost like a ceiling that is created.
It is a thermodynamic ceiling above our troposphere. And that's why our weather never trickles. Yeah, okay. It's a lid.
That's so cool.
Containing basically all of our weather.
That's amazing.